start. Before going to the line clipping, what is the meaning of a clipping? In last video, we know about the window port and viewport, right? So how the viewport will be clip the windows extra patterns, or we can say a lines or a diagram. You will clip and it will take in the zoom order with display, right? That is a viewport. The hair clipping, the procedure that identify the portions of a picture that are either inside or outside of the specified region of a space is referred to as a clipping algorithm or simply a clipping. What it means? It means suppose we have a window, means this is your given window. In that the image have given, it will, sorry, here the image will be inside the window, right? So we want to view that particular image or a part of a image. In that this part, this is your viewport. In this viewport it will highlight and show the image of your zoom part, right? This is your viewport image. So how it will, this is called a rectangular window, huh? So this part is whole is window, this is we are clipping this one, the image is clipped here and displayed in this here. This is how you are to clipping. So the region against which an object is to be clipped is called a clipped window. A clipping refers to the removal of a part of a screen where the internal clipping removes a part of a picture outside a given window, while the external clipping removes a part of inside a viewing window. See, with the example we will get it easily. Right? This concept is so easy to understand. Okay. Next, here we know viewing requires us to define a viewing window, often referred to as a clipping window. Okay. So here there are a number of algorithms are there, namely 4 types of line clipping algorithms are there. So in this video we focusing on a Cohen Sutherland algorithm, that is clipping the line. Okay. So the window may be the clipping window may be a rectangular or maybe a circular or any arbitrary space. So here point clipping also is there, line clipping is also there. We focusing on a line clipping, and point clipping means nothing but your pixels will be with the windows, it will clip that one. Means the algorithm finds all the points that are interior to the clipping window. Any point that is x, y is said to be interior to the clipping window if it satisfies x is greater than or equals to x of left corner and x will be less than equals to right. Means what they saying, this is for a point clipping, right? So here the clip x and y, this is your point, is x is greater than equals to left one, okay, and it should be a less than equals to right side of the window, and y is at the top and bottom, right? And y means this pixels coordinate x, y is greater than equals to y top, okay, and it will be less than or equals to bottom. If satisfies this condition means the pixel or a point is within the window, right? Then how the line clipping are done in a computer graphics we'll see. There are mainly 4 algorithms are there. First one is Cohen Sutherland line clipping, midpoint subdivision algorithm, and Cyrus-Wake line clipping, and last one is Langbarsky line clipping algorithm. Okay, in this video we focus on a first algorithm, that is a Cohen Sutherland line clipping algorithm. Okay. So Cohen Sutherland Line Clipping Algorithm. How it works in a computer graphics we'll see. Basically, it uses a 9 region code. Okay, the window given is that in last video how we see the view and window clipping. Here the window means that will take the 4-bit digit of a binary, means zeros and ones we are indicating using a 4-bit 4 digit of a binary. It's based on how we calculate this one. Using a x max means it will give the higher value of your window, and y max that gives the height of your window. X min will be starting with start, and y min is gives the a window total. So based on this 4-digit binary number, we concluding the windows part first. Okay, so remaining 8 parts will be assigning using the a formula is there, that is a top, bottom, right and left of a using this right, top, bottom, right and left, assigning the values according to the windows. Means how we have to assign this window part digit value, how we have to assign. See, this is not in a top, right? It's not in a top, it's not in a bottom as well, and it will not in a right side, and it will not in a left side. So that's why the window always initialize with the 4 zeros. Okay, so what it indicates? 0 means if a line is given, the line is appearing both the points starting and ending point in a same window, means that is gives a fully visible. If it will intersect the window's boundary, then taking the help of a formula, we are calculate the intersecting point of both end points, and then it will be partially visible. We say that one as a partial visible. So how we have to assign these a 9-digit code? Among 9, we know window get the 4 zeros. Okay, so the center part of is viewing region or a window, you can say. All the lines which lie within this region are completely visible. Okay, right? A region code is always be assigned to the endpoints of the given line. Remember this, we are assigning the a digit 4-digit binary number of the endpoints of a given line. Okay, with the help of example we can easily understand. It is an easy concept to learn, and bear with me to check whether the line is visible or not. Okay, so what is the formula? The top, bottom, right and left. Accordingly that we have to assigning the 9 region code. Okay, see next, this is a given. Here we assign the region code. How it appears, I will explain now. Okay, so using the top, bottom, right, left, the sequence is same. You have to remember this sequence only. Okay, top window, how we get? It is not in a top, not in a bottom, not in a right or not in a left. For that, the window is initialized with 4 zeros. This is part we having a right of windows right. So right means where the right is there, we have to initialize with 1 and remaining are 0, because it's not a top, bottom, it's a right. For that's the reason we assign the 1, and left is not there, so we have to assign 0. Like that we have to repeat the top right, means it is a top, that's why it will give the 1010 for this region code. The top right region code is 1010. What is the bottom right? It's a 0110. How you get this? Because it's not a top, right? That's why 0. Bottom is there, right, and left. Right is there 1 and not it's a left, so that's why it's a 0. Here bottom left. So top is not For that it will 0. It's a part of right. So it will give 1. Right is there? No, it's a left side. So right will be 0 and left will be 1. So left region code is 0001. Top left is 1001. Top is 1000 and bottom is 0100. This is how we have to assign the 4 bit of a binary code of each region code. How many region codes are there? Total 9. Our window part is 4 zeros and remaining are have to use the top, bottom, right, left formula. Based on that, you have to assign the assigning the code. We'll see the algorithm now. So what are the steps? First step is to assign the region code to the both endpoints. Endpoints of what? A given line. Okay. So with the help of that, we are taking the window and we take the region code. Okay. This is how we have to write down the all the region code. What they saying? We have the line P1, P and Q. Okay. So based on this, we have to assign the region code of this P and Q. If both the end points are getting the 0, means performing the OR operation, we get the end result is 0 for P and Q. If a line is like this, this is your A and B line. Second line, this is. So first what we have to do, take the region value of A. Okay, 0001 is there and B is 100. So we see the 1 is appear from the 4 digit binary digit, we get the 1 means we have to perform a AND operation. Okay, what we get the after performing AND operation of this A and B region code, we get the 00. If not, means we have the like this line. This is called a CD line. Okay, the both if you performing a AND operation of a C region code and D region code, we get a 1 means this line will be discarded. Why? Because it will not get the 0 values of a 4-bit number. Okay, if you get the 4 all 4 are 0, then it will be performing a clipping, means it is partially visible. If without performing AND operation, we get the both the endpoints are 0, then it will be fully visible. I hope I clear this up. Means what are the lines are a clipping will be performed and how it will we see, and what are the type of clear lines are discarded, means will not clip and it will be totally invisible in the window. I hope this is clear. First, if we get the all 0 after performing a PQ region values, we get a 0 means it is fully visible. So the AB are the, we know the value of a left region is 001 and 10 sorry, B is here. So 100. So performing AND operation, we get a 00. Then this line is partially inside the window and considered for the a clipping. Okay, how we have to do this? Because part of our line are a left region and a top one. So after confirming that the line is partially inside the window, then we find the intersection with the boundary of the window. Means we have to consider that the line is partially inside. How we get? After performing the AND operation, we get a 4 zeros. So for that, we have to first step need to find out the slope. Slope formula is m equals to y2 minus y1 divided by x2 minus x1. How we get the y1, y2 and x1, x2? With the lines. The lines end point is there na. So starting points x and y value have to take a x1 y1 and end point we have to take the x2 y2. So after getting the slope, now if the line passes through top, As we know, in our example, a B is in a top, or the line intersect with the top boundary of the window. Then how we have to get the x value? The x equals to x plus y w max minus y divided by m. Okay, here what is the x and y? The point value. It means we got the a B point, right? So B points value have to take and find out the x value and y value. Here top we have to divide the slope value. Okay, remember that here the trick is there. We have to, in top we have to find out the x value equals to x plus y w max minus y divided by of a slope, and y is y w max. W is windows max. Okay, next, this is for a first condition, means that points will be on a top. If the line passes through the bottom, means bottom side, or the line intersect with the bottom boundary of a window, then how we have to find out the x value? X equals to x plus y w mean minus of a y divided by m. Okay, so this is your window, your point will be here intersecting here. So for this we have to find out the x value with the x equals to x plus y min, means a minimum, y minimum is here, right? So for that y minimum minus of y and divide by the slope. And what is the y value? That is a y min value. And C condition means the line passes through the left region, means the line is from this side, as your example A point. So how we have to find out the intersection points of a boundary of a window? Then how we have to find out the x? X will be xw min, means point is here, right? So for that x will be minimum, and y, how we have to find out the y value? That intersected here, right? So for that y equals to y plus xw min, okay, xw min minus of x, and here slope will be multiplied. Okay, remember the difference between top bottom, we dividing the slope, here left right we have to multiply with the slope. Okay, so what if the line passes through the right region of the line intersect with the right boundary of the window? Then x will be x max, means the point is here. So here what we have the max of a x max. So x value will be x max. Y is y equals to y plus x w max minus of x and multiply with the slope value. Remember, these four are most important. With this we can get the clipping of our lines. Okay. So next, now the overwrite the endpoints with the new one and update it. Okay, once we get the values, and we have to take the update, and endpoints will be changed. That A is there, A dash, and B is there instead of B dash. That intersected parts we have to update it here. And repeat the fourth step till the line doesn't get completely clipped. Okay, given a set of lines or rectangular area of intersects, the task is remove lines that are outside of the area of a intersect and clip the lines which are partially inside the area. So this is the line clipping algorithm of a Cohen Sutherland. In next video we see the with example we solve the one numerical of a using Cohen Sutherland. Okay, thank you.